Today we are going to work on Learning Target 4 from Unit 5, which is I can explain and apply the Pythagorean Theorem and its converse. Important elements for the Pythagorean Theorem that we need to understand before we can apply it are the different parts of a triangle. So if you look at our parts of a triangle on the left side of the page here, sides A and B are going to be called the legs of our triangle, where side C is going to be called the hypotenuse. And you'll always be able to tell which side of the triangle is the hypotenuse because it's going to be the longest side of the triangle. Another indicator is that it will always be the side opposite the right angle. Always. And one thing to remember with the Pythagorean theorem, it is also only good to be used within a right triangle. So if you don't have a right triangle, unfortunately we cannot use the Pythagorean theorem. So the Pythagorean theorem is used to find a missing side length on a right triangle. And you may have already encountered this formula. It's a very popular formula across the math world. You'll find it in many television shows and plays and movies. When people want to sound very smart with math, they'll use the Pythagorean theorem to make a point. So the formula that we will be using for Pythagorean theorem is a squared plus b squared equals c squared. So we would read that as one leg of our triangle squared plus the second leg of our triangle squared is going to equal the length of the hypotenuse squared. So if we look at example 1a, we are being asked to find a missing side. And if need be, we are going to round to the nearest tenth. So looking at what values I'm given a side length, so I'm given my two legs, and I'm looking for my hypotenuse. So if I use the formula a squared plus b squared equals c squared and substitute in the values that I have, it does not matter which value is substituted for a and which value is substituted for b. So if I rewrite this, I would get 12 squared plus 9 squared equals c squared. And 12 squared, 12 times 12 is 144, plus 9 squared, which is 9 times 9, which is 81, equals c squared. And 144 plus 81 is equal to 225. Now this is where we may run into, not trouble, but we would just have to refresh ourselves on how to use our calculator. So in order to find the value of c, I have to do the inverse of squaring a number, which the inverse of squaring a number is to take the square root of said number. So if I take the square root of both sides to keep it equivalent, that would give me c equals, and then I have to take the square root of 225. You could ask yourself what number times itself is going to equal 225. However, if you don't remember quite how to do that, you can go to your calculator, and if you type in second x squared, because we are focusing mainly on this square root button, you'll get a symbol that looks like this on your calculator, and then you'll type in 225 and then press enter. And when you do that, you should get that c equals 15. So our missing side length is equal to 15 inches. If we look at example 1b, we're asked the legs of a triangle are 12 inches and 16 inches. Find the hypotenuse. If it helps, go ahead and draw out your right triangle. So the legs are 16 inches and 12 inches, and we are searching for our hypotenuse. So we'll use the same formula, a squared plus b squared equals c squared. So again, it does not matter which value I substitute for a and which value I substitute for b. So 16 squared plus 12 squared equals c squared. So 16 squared is equal to 256 plus 12 squared, we already did that in our previous problem, 144 equals c squared. If we add 256 plus 144, that equals 400. So our hypotenuse squared is equal to 400. And again, I need to figure out what the value of the hypotenuse is without being squared. So I'm going to do my inverse operation, which is taking the square root. And the square root of 400 is equal to 20. So again, just a reminder, if we're typing it into the calculator, we would press the second button. We would press the x squared button, which is going to give us that square root symbol. We also call it a radical. And then we would type in our number and enter to get our square root. So if we look at example 1c, notice here we are given the hypotenuse and we are in search for one of the legs. So I'm going to use my same formula, a squared plus b squared equals c squared. However, when I substitute my values in, I need to make sure that I substitute them into the correct locations. So a and b are legs. I only have one leg available, so I will put that in for a. So a squared, or 8 squared, plus my missing leg, which is b squared, equals my hypotenuse squared, which is 24 squared. 8 squared is 64 plus b squared equals 24 squared, which is 576. And then I would solve this as I would any two-step equation. I'll subtract 64 from both sides. So we get b squared is equal to 512. In order to get the value of b, I have to take the square root. So b is going to be equal, we get a decimal, 22.627417, and in our directions it did say round to the nearest tenth, so we would write 22.6 meters. And I believe I forgot my unit on letter B. That would be 20 inches. Alright, and 1D says find the missing leg of a right triangle with a hypotenuse of 12 feet and a leg of 10 feet. So again, I have the hypotenuse and I have a leg, which means I'm looking for the other leg. So a squared plus b squared equals c squared. My one leg is 10 squared plus my missing leg, b squared, equals the hypotenuse squared. So 10 squared, 10 times 10 is 100, plus b squared equals 12 squared, which is 144. Solve our two-step equation here. Subtract 100 from both sides to keep it equivalent. B squared equals 44. And then take our square root of both sides of the equation, and the square root of 44, we get 6.6332, so on. We're rounding to the nearest hundredth, so we would just leave it as 6.6. So our solution would be 6.6 feet for the length of our missing leg. So that is how you apply the Pythagorean theorem to find a missing side length. The Pythagorean theorem can also be used to verify if the triangle is a right triangle. So we said that the Pythagorean theorem is only works when you have a right triangle. It's also a way that we're able to tell if a triangle is a right triangle and has a right angle across from the hypotenuse. And using the Pythagorean theorem to distinguish whether or not a triangle is a right triangle is called the converse of the Pythagorean theorem. And this helps us, again, prove whether or not it's a right triangle. So if we look at example A and example 2, determine if a triangle with the side lengths 10, 15, and 20 form a right triangle. So the most important thing when you're looking at these questions is you have to distinguish which value is the hypotenuse. And the quick trick for that is the longest side is going to be your hypotenuse, which we talked about when we first began. So I'm going to go back to my a squared plus b squared equals c squared, and I'm going to substitute in the values that I have. So 10 squared plus 15 squared, does it equal 20 squared? So 10 squared is 100, plus 15 squared, which is 225. And again, does that equal 20 squared, which is 400? So 100 plus 225 is 325. Does that equal 400? We can very clearly see that it does not equal, 325 does not equal 400. So we would say this is not a right triangle, because the side lengths and hypotenuse, well, the side lengths do not satisfy the Pythagorean theorem. So let's look at 2b. It says determine if a triangle with the side lengths 5, 12, and 23 form a right triangle. So again, I have to identify my hypotenuse. 23 is the longest side. So that's going to be my hypotenuse. So a squared plus b squared equals c squared. If I substitute the values in, 5 squared plus 12 squared equals 23 squared. And we want to see, is that true or false? So 5 squared is 25. And we're going to add that to 12 squared, which is 144. And does that equal 23 squared, which is 529? And I think our math skills are pretty strong. We can see that that is definitely not going to be equivalent. 169 is not equal to 529. So this is not a right triangle. Alright, I want you to go ahead and try example 2C and 2D. So pause the video now, and when you restart it, you will be able to check your work with my work. So go ahead and pause right now. Okay, so go ahead and check your work. If you look at example 2C, when we plug in the numbers, 25 should have been your hypotenuse, and when you plugged in the two legs, 7 and 24, you squared them. It did become equal to, or it is equal to, the square of the hypotenuse. So that means that that is a right triangle. And on 2D, again, we identified 53 as our hypotenuse because it was the longest side. When we plugged in our values of the legs and we squared them and added them together, we found that it did not equal the square of the hypotenuse, which was 53. So if you have any questions, write them down, but you can begin to work on your practice. Make sure that all of your work is shown. Have a good day.